Hi guys, welcome back to another episode of SumPy. Today we'll be looking at vectors, a topic which students tend to run away from in a particular direction. That is the opposite. So guys, today we are going to try to have you guys enjoy this topic and realize that vectors are as simple as, let's just say, a walk in the park in the right direction. That was a little joke. Okay, guys, so vectors. What is it? Is it a straight line? Is it a array? I mean, so many definitions out there. Sometimes I'll tell students that a vector is just pretty much, it visually looks like the segment of a line or portion of a line that's straight, and it tends to have an arrow. That's what I tell a lot of students. But a vector depicts so much more. First of all, two of the key characteristics of any vector is, firstly, a vector must have something called a magnitude. Now, if you guys know what the word magnitude means, it means length or size. So if we're talking vectors and we're thinking about straight lines, then the first point about that straight line is that it should have a particular length. So a vector is definitely can have like a finite measurable length from one point of the vector to the other point. Now, besides having a length, every vector must also have a particular direction, and that direction is usually denoted by the presence of an arrow. So, for example, if I wanted to call my first point here A and my second point B, and I wanted my vector to be called AB, where we are starting from A and we are ending, or let's just say walking towards B, then our straight line should have an arrow that denotes direction from the point A towards the point B. This is how vectors are written standardly. They have something that looks like a little cap with an arrow above it. It contains the two letters that represent, the first letter represents your starting point on that line, and your second letter represents your finishing point. Where are you walking towards? Where are you going towards? Where are you stopping? And of course, the small little icon that looks like an arrow always points towards the right, and it simply denotes the direction in which you are starting and ending. So once again, to recap, every single vector should have a magnitude, which is a specific length, and it must have a direction, which is denoted by the presence of these little arrows here. All right, so now that we kind of cleared that up, I'll move on to showing you guys a couple more key features about naming vectors based on what they look like. So for example, let's just say you were given 2 points, P, and then we have Q here, and we had an arrow pointing in this direction, and they are asking us to name. What's the name of this vector? Well, first of all, to name a vector, you must identify your starting point. And I can safely see that my arrow is pointing away from P and towards Q. So our starting point seems like it's P, and therefore our last or ending point is Q. So if we had to name this vector, it would be called PQ, and we will place that little hat, that little arrow direction above to denote that this is a vector that's traveling from P towards Q. So that's the first example there. What about if we had something like this? Let's just say we had C, D, and our arrow was pointing in this direction. How would we name this vector? Well, once again, based on the direction your arrow is pointing, we are starting from C and ending towards D. So this vector will be named CD with our arrow pointing above in that direction towards D. Now, it should be important to note that after you have named a vector, if the direction is changed, then the sign in front of your vector is also changed. Let's look at a third example so I can explain this more clearly. Let's just say, for example, we had 2 points on a line. Let's call this AB again. So we have AB, and this time what we're going to do is we're going to give AB a magnitude or a length. We're going to call that X. So from A towards B has a magnitude X. Now, in naming our vector, of course, our vector will be called AB in the direction where we are moving from A towards B, based on our directional arrow present. But now we actually have a value or a magnitude for our vector. And that magnitude was given by the letter X. Now, what if someone were to ask, well, if you know the length or the magnitude of your vector AB, can you tell us what the value of BA would be equal to? That's an interesting question. But if you really consider the fact that the distance between the 2 points AB is the same as the distance between the points BA, because your length is not changing, then the length of the vector B to A will also be equal to X. Now, those answers can be right. The vector AB can never be equal to the vector BA. What's missing? Well, remember, with vectors, we have 2 points to consider. All vectors have a magnitude, but vectors also have a direction. So we need to take that in account. You see, when we were considering the vector AB, we were considering it moving from our left towards our right. But now, the vector BA is actually moving in the opposite direction. So we need to account for this by simply placing a negative sign to denote a change in direction in front of our magnitude. Therefore, at the end of the day, our vector B to A has a true value of negative X. And that negative sign simply denotes that there's a change in direction. Okay, so those are some key features that I wanted to highlight in today's lesson. I would also like to get into what is a position vector with respect to the Cartesian plane in this lesson as well. So I'm going to move on here. See if we have enough space. Yes, we do. Okay, no, I think I'll clear my screen. Okay, let's clear there. Okay, that looks good. Right, lovely. All right, guys, let's get a move on. So I'm going to draw a Cartesian plane here. All right, 4 quadrants present. We have our x-axis. We have our y-axis, and of course we have our origin. Now, you guys are familiar with the origin. Origin takes place at the coordinates 0, 0, where for those of you guys who forgot, coordinates are written in the form x, y, where your x coordinate is written first and your y coordinate is written second. Now, because essentially vectors are typically, well, they are rays, but they are straight lines as well. We can actually represent vectors on a Cartesian plane. And if you were to start a vector, start drawing it from the origin, for example, let's just start a vector from our origin. And let's say we have a straight line going in this direction, and we're going to call that P. Also, I'm going to give the coordinates on the x and the y axis so that we know the coordinates of our point P. Let's just say this has a value of 3 on the x axis, and we have a value of 2 on our y axis, such that P has coordinates 3, 2. Please remember that a coordinate is always written horizontally. Now, if I wanted to represent, the vector OP, how can I do this? Well, observing our Cartesian plane, we see that in order to move from a point O towards a point P, we first need to move 3 places to the right and then 2 spots above. Now, when you are representing vectors that are located on a Cartesian plane, there's a special way that we represent this vector, where the top value, simply the distance in the positive direction from that origin, and the lower value is the distance from the origin above or below. Now, in this question here, P, we have that located positive 3 spaces to the right, so our top value will simply be positive 3. Similarly, P is located 2 spots above our origin, that's positive 2 spots. So we will have a value of positive 2 written inside that bracket. Now, if you were to compare the way a coordinate is written horizontally, because we have a coordinate here, the coordinate P has values 3, 2, and the vector also has values 3, 2. The only difference here is that it seems like the coordinate has somewhat been transposed vertically. So this is an easy way you can remember. Anytime you want to write a vector that's starting from the origin and you know the coordinates of the end point, you simply transpose the coordinate from a horizontal to a vertical position. And that's how easy it is to convert a coordinate into a vector. Vectors that start from the origin are also called column vectors. They are all called column vectors, but not all column vectors are, let me scroll up here, not all column vectors are position vectors. Now, what is the difference? Position vectors always start from the origin. Now, what on earth do I mean by that? So for example, in this question, I am telling you guys that the vector OP is a column vector, but it is definitely a position vector because the first starting point is the origin. If I were to draw another vector on my graph here, let's just say I'm going to have my value here as 1, 1, and I'm going to end it at, let's just say this is also 3, and let's just say this is 3 here. So this point we can call A, this point we are going to call B, and let's have our vector traveling in the direction A to B. So observing this second quadrant here, where we have the vector AB going from A towards B, how many spaces to the right would we have to move? Well, let's think about it. From A starts at 1 on the x-axis. We need to jump 2 spaces to get towards 3. So our x direction would be 2. However, we are moving to the left. So that becomes -2. Also, how is it possible for us to move vertically from this point to reach B? Well, we are starting once again at a value of 1, and we need to jump 2 spots up to reach 3. So that's 2 spots up means the positive direction. So that y value remains as +2. So the vector AB in this example is represented by -2 spaces to the left and then 2 spaces up. Now, is this a position vector? Well, because our first starting point is not the origin, this is not a position vector. All position vectors start from the origin. And this is very, very important to understand. There is a difference. All vectors, because they are written vertically, they are considered to be a column, because columns are written vertically. So all vectors are column vectors, but not all vectors are position vectors. Only if your first letter is the origin, then it's called a position vector. Okay, so on this diagram, once again to clarify, we have 2 column vectors, one of which happens to be a position vector. Our position vector in this question is O to P. AB is just a regular column vector. Okay, guys? So I hope that clarifies some of the basics on vectors that you may have had issues with understanding from the beginning. I forgot I erased my page, man. Understanding, first of all, what a vector is, the fact that it has a size and a direction, the fact that it's denoted by 2 letters with a little hat on top, the fact that it has a starting and an ending point, the fact that it's also written vertically. It looks like a column. The fact that if you're given a coordinate, you can just transpose it into a column with the x value on top and the y value on the bottom, and that'll be your answer for the vector. You can also count spaces to the left or right, spaces to the top or bottom on an actual Cartesian plane, and you can get your vector. And then all vectors are column vectors because of the way they are written, but there's special vectors called position vectors, which always start from the origin. So that ends my session for today on the very basics of vectors. Please look forward to next session when we will finally be getting into using that vector rule to do some calculations of addition and so on. So it was good to be with you guys. I hope this lesson was very informative, and take care. See you soon. Bye.